Okay, so why did we learn about the discriminant and what does that actually mean when I say that there's two real solutions versus one real solution versus two complex solutions? So we're going to be jumping into graphs of quadratic functions in the next section in this chapter, but I wanted to just, put some context to why are you even learning this, right? Like, why is it important? It might seem a little arbitrary. So I'm going to put up these three graphs. So as you'll see, when we graph quadratic functions, they turn into this U shape called a parabola, okay? And they can be facing up and down like a smile, or they can go from top to top or from bottom to bottom like a frown, okay? So those are the two types of parabolas you'll see when we graph quadratic functions. And when we graph them, one of the things we're going to be looking for is something called an x-intercept, and that's exactly what it sounds like. It's where our graph intercepts the x-axis, okay? And you guys, for a very long time now, have been solving for x, right? Like if we have x squared plus 2x minus 6 equals 0, right? We can use the quadratic formula to solve for x. What are we actually doing when we solve for x? We're finding something called the zeros, or the roots, or the x-intercepts. They actually go by three names. But you're finding where is the graph of this quadratic function, the graph of this parabola, where is it going to cross the x-axis? That's what you're finding. Okay, so when you solve for x by either factoring or using the quadratic formula, and you get x equals plus or minus whatever, okay? Then we're actually finding the points where the parabola crosses the x-axis. And so as it turns out, if the discriminant, right, b squared minus 4ac, if that's greater than 0, we learned that there will be two real solutions, which just means there's two x-intercepts. There's actually two places where this parabola will cross the x-axis, okay? So that's what you're actually solving for. If the discriminant is equal to 0, we learn there's only one real solution. That's because the vertex of this parabola, the very tip of it, is the only place that will touch the x-axis. That means the very tip of this parabola is only touching, it's the only part that's touching the x-axis, which is why there's only one real solution, okay? Because it's just this one point where the parabola touches. And then when we have two imaginary solutions or two complex solutions, right? When our discriminant, b squared minus 4ac, is less than 0, we have no x-intercept, right? And that's because, look at the graph of our parabola. This is what's actually happening when we have a discriminant that's less than 0, a negative number underneath that square root. That means that our parabola isn't touching our x-axis at all. It does not cross it, okay? And so it would look like this. And in that case, we have absolutely no x-intercepts, right? Because we have two complex imaginary solutions. So when I'm asking you to find, the discriminant, the types, how many solutions and what type, right? I'm asking you to find where is the graph of this parabola crossing this x-axis. If it's hitting it twice, those are two real solutions. If it's hitting it just at the vertex, the very tip, that's the one real solution. And if it's not hitting the x-axis at all, then that's when we have two imaginary solutions. So I just wanted to give you a little context to that. And we'll see this more and more as we get into the graphing in the next section.